Okay, now let's start a new module which is focusing on Administer Intersite Connectivity. I hope you have gone through the previous lab and you know how to deal with virtual networks in Azure Cloud. If you know that thing, let's talk about how we can do one network to another network kind of a connectivity. In this module, first we are going to talk about configuring virtual network peering. Peering is one of the easiest way to connect one Azure virtual network with another one. Maybe both belongs to the same region, or maybe both are global, so you can do a global virtual network peering to connect one network with another network across the globe. We are also going to focus on managing, controlling traffic flow with routes, and then after this we have a lab associated with this module also. So let's start with first configuring virtual network peering. In this module, we are going to focus on what and where exactly we are going to use virtual network peering. Then we are going to focus on determining gateway transit and connectivity needs according to that. And then we will see that how we can create virtual network peering, determining service chaining uses which are associated with that. Now, have a look at this particular slide. As you can see here, virtual network peering is allowing you to connect one virtual network with another virtual network. Now, when we say this thing, there are chances that you are connecting two different virtual networks within the same Azure region, like VNet-2 and VNet-3 in this particular slide. Or maybe you're going to configure one virtual network from one Azure region to the another virtual network in the different region altogether. And that is something like VNet-1 and VNet-2. And that's something which we call global VNet peering. So basically, there are two different types of VNet peering we have, global and regional. And when we try to do this thing, you can actually peer virtual networks across Azure subscriptions and tenants also. So there is no subscription or tenant boundaries which are going to create issue with this. Also, when you're dealing with this thing, it's going to have a preferred network as Azure backbone for the privacy and isolation. So basically, virtual network peering is having all the advantages. It is easy to use. It is having seamless data transfer associated with that. It's going to provide great performance, and it's going to use Azure backbone network. So it's going to be secure also. Now, if you have a look at this particular slide, the diagram which I'm showing you here is one of the most important diagram for Azure infrastructure. As you can see here, this is something which is known as hub and spoke network topology. Now, you can also search this thing on any search engine to know more about that. But in this case, we have one virtual network which is at the center of this, which we are treating as a hub virtual network. And the left and right side one are actually the two different virtual networks with the name virtual network A and B. Both are nothing but treated as a spoke. Now, when you want to connect multiple virtual networks with each other, hub and spoke is one of the useful topologies associated with that, where we are going to treat one virtual network as a center, and then all other virtual networks are going to connect with that as a spoke. In this case, you can also check that there is a VPN gateway which we have configured in our hub network. And that's the reason I want you to know that gateway transit is going to allow peered virtual networks to share the gateway and get access to the other resources. Remember, no VPN gateway is required in the peering spoke virtual network. So you just have to set up that thing in the hub, and then your peering spoke virtual networks do not require a separate VPN gateway. Also, the default VNet peering is going to provide full connectivity without any VPN gateway required with that. Now remember, in this case, your IP address spaces for connected networks can't overlap. This is something which I've told you in the previous module also, that you have to take care of the overlapping of the private IP addresses. And if you have taken care of that thing, you're always going to be enjoying connecting one virtual network with another virtual network without any hassles. But yes, if you have overlapping networks, it won't allow you to connect with virtual network peering. This is a screenshot which is actually showing you how exactly we can add peering. Remember, when we are going to do the lab, we are going to create virtual network peering. So basically, you have to provide a peering link name, which is a user-friendly name which you can provide to establish a connection between two different virtual networks. Also remember, when you're doing this thing, you can configure certain things like forwarded traffic rules as well as the remote peering link name kind of a connection. Make sure once you're done with this, if the status of this connection is showing you connected, then only two virtual networks are actually connected. Somehow, because of overlapping or some other issues of security related things, if your virtual network peering is showing you a connection status which is not connected, then maybe you have to check the other things to troubleshoot what is the issue with the connection. This particular slide is actually talking about service chaining. Now, as we discussed, we have hub and spoke kind of a virtual network topology which is available. Service chaining is actually going to enable you to direct traffic from one virtual network to a virtual appliance or another virtual network or a gateway kind of a thing. Now, when you do this thing, this is something which is a preferred virtual network through user-defined routes configuration which is there. It's going to leverage user-defined routes and service chaining to implement custom routing, and then it's also going to implement virtual network hub with a network virtual appliance or a VPN gateway. Basically, this service chaining kind of a configuration is going to help you to configure and connect your multiple virtual appliances with multi-network kind of a scenario. Hey guys, sorry for interruption. My name is Maruti and I'm here to make a very important announcement. I hope you are liking our videos and you're doing a continuous learning with us on an Azure Cloud and AI related topics. If you are enjoying this thing, I'm going to announce SkillTech.club, which is our upcoming website, which is going to be launched very soon. We are here to tell you one thing, that everyone who is a subscriber of this particular channel will get Azure Cloud and Azure AI related certification courses free of cost in SkillTech.club. So you will be a part of the SkillTech.club kind of a membership automatically free of cost. And everyone who's a subscriber of this particular channel will get those benefits which are available in that. So what are you waiting for? I request you to please subscribe to this channel and share it with your friends and families if they are also interested in Azure Cloud and AI learning. That's it from my side. Now you can carry on with your learning. Thank you. Now let's understand how can we manage and control traffic flow with routes. In this case, we are first going to find out system-defined route and user-defined route kind of a configurational differences. I'm going to focus on configuration and comparison between those two. We'll determine something which is known as service endpoint, and then we'll see where exactly we can use this thing. Also, we are going to talk about something called private links usage. Now, obviously, these are some of the common questions which people ask, like what is the difference between system route and user-defined route? And what is the difference between service endpoint and private link? Now, you're going to get the answer of this thing in this module. Now, let's start with system route. Remember, Azure automatically creates system routes and assign the routes to each subnet in a virtual network. So whenever you create a virtual network, whenever you configure subnet inside that, system routes are going to be configured automatically by Azure. You cannot create system route and you cannot remove the system route, but you can override some of the system routes with your custom route configuration. When you're doing this thing, as you can see in the slide, we have some front end and back end kind of two different subnets which are there. And there are some system routes which are configured with them. So whenever you want to transfer data from one to another network or a subnet, it's actually going to use this kind of a system route. When you create a custom route, you have to, by following user-defined route configuration with that, which is going to be UDR, or maybe you're going to use BGP, Border Gateway Protocol kind of a protocols with that, which is actually going to help you to route between your on-premise network gateway and Azure Virtual Network Gateway kind of a thing. Now, when you do this thing, this network routes are going to help you to transfer the traffic between virtual machines within the same subnet, or maybe within the different subnets in the same virtual network. Sometimes it's going to help you to control the data flow from virtual machines to the internet also, as well as it's going to help you to communicate between virtual machines using VNet-to-VNet kind of a VPN. Now, we are going to talk about something called site-to-site or point-to-site kind of a connections in the coming modules, but that is where you can actually use system routes and it's going to help you to communicate between these things. You can also use site-to-site kind of an ExpressRoute communication through VPN gateway if you want a really high bandwidth kind of a configurations with that. So basically, you use this system routes with VNet peering, or maybe VPN gateways, or maybe ExpressRoute circuits. It's up to your choice. So system routes is what you're going to use, and sometimes if you want to configure, you can create custom user-defined routes also. And that's why let's have a look at user-defined routes. And in order to understand user-defined routes, you have to understand one thing which is known as route table. In Azure, when you create a route table and then you associate the route table to 0 or more virtual network subnets, each subnet can have 0 or 1 route table associated to it. Now, in this case, each route table can be associated to multiple subnets, but a subnet can only be associated to a single route table. This is how the connections are going to be done. And then there are no additional charges for creating route tables in Microsoft Azure. If you want to use route tables, you have to configure that accordingly. Now, every time when you're doing this thing, a route table is nothing but is going to contain a set of rules, which we call routes. And then basically this is the configuration which is going to specify how your packages should be routed in a virtual network. As you can see in this particular slide, we have user-defined routes which we have configured from front-end subnet to my virtual machines which are associated with that. Now, user-defined routes are nothing but custom routes that control network traffic by defining routes that specify the next hop of the traffic flow. And obviously, this is going to be establishing like a direct connection from those virtual appliances and the network. The next hop can be a virtual network, it can be a virtual network gateway, it can be an internet or any other virtual appliance associated on the Azure cloud or outside. Now let's talk about the fourth important concept, which is known as service endpoint. In Azure Virtual Network, service endpoints are going to provide secure and direct connectivity to Azure services over an optimized route over the Azure backbone network. Basically, service endpoints are going to enable private IP addresses in the virtual network to reach the endpoint of the Azure service without needing a public IP address on the virtual network. Now, because it is possible to do this thing without public IP address, is basically going to be one of the secure way to do the connection and communication. When you do this thing, it's going to improve your security for resources, it's going to be optimal for routing for your service, and it's going to use Azure backbone. So it is going to be a very simple to configure, and it's not going to use a public internet associations with that. As you can see in this particular slide, we have an add service endpoint kind of a configuration which I'm showing you, in which you can associate with which kind of an Azure resource you're trying to configure this service endpoint. We are selecting Azure Storage in that particular screenshot, but you can choose whichever you want. Also make sure that whenever you are adding a service endpoint, it can take up to 15 minutes to complete that process. And only after that, it is going to be allowed to communicate using a service endpoint. Finally, let's talk about the last point of this particular module, which is private link. Azure Private Link is going to be enable you to access Azure Platform as a Services kind of resources. So let's say you want to access Azure Storage account or Azure SQL database or any other platform as a service kind of a service, then you can use Private Link. And it's also going to help you when you want to associate with Azure hosted customer owned partner services or private endpoint kind of a configurations with virtual network. The traffic between your virtual network and the service is going to travel to the Microsoft backbone network, is going to exposing your service to the public internet is no longer necessary. So this is also going to be a secure way to associate with that. And that's the reason the name is something which is known as Private Link. Now, service endpoint also offers an easier access with less security, whereas private endpoint is going to provide more granular control and better isolation. So basically, if you ask me that how is it different than service endpoint, because both are using Microsoft backbone network, both are secure, well, somehow private link is going to be more secure because it's going to give you a specific secure endpoint associated with that. And then it's going to give you a better isolation also compared to service endpoint. In most of the time, when you're going to associate a connection with your on-premise network or with the peer network, you're going to go with the private link only. Now, in the event of security incident within your network, only the mapped resources would be accessible, which are associated with the private link, not all the other resources. So when this kind of things are there, private link is actually going to provide a better security and more manageable kind compared to service endpoints. With this, I think this module is also done. So let's get started with this particular lab so that we can understand this better.